Hello everyone. Now today we will be learning how to compare two trigonometric functions with help of their graphs. Now please, those who have not watched previous videos where we have discussed how to draw graphs of trigonometric functions, my request to them is first go through them. Now in every video in our description part we give video links of prerequisite. I mean, like if this video is to be understood, you should know how to draw graph of trigonometric functions. So I'm saying open that link, go through that video, understand every small thing discussed there, and then come back to this. And same as with the end of the video also. There also I try to provide some video links. Now, like you should get habit of seeing the video, watch the video till the end. When I say watch the video, it's not only watching by your eyes. It should be that you sit with your paper, pen, etc. Try to draw those graph like or whatever important points I am mentioning there and make your own notes side by side. Okay. So let's start today's session. Now here I'm taking as an example like two functions. I'm taking them specially as sine and cosine because we have recently done them. And my interval where we are going to compare them is 0 to pi by 2. And it's an open interval. Okay. And we have to compare. Now, how to start? Now, as my topic suggests for today's session, that it is application of graphs of trigonometric functions. So obviously, I expect you to draw the graphs of y equal to sin x and y equal to cos x over the interval 0 to pi by 2. Okay. So mark pi by 2 and try to draw graph between 0 and pi by 2 of sin x and cos x. So y equal to sin x and y equal to cos x is in front of you. Now you can see that these two graphs intersect at a point. Okay. What may be that point? It is pi by 4. Cos pi by 4 means cos 45 degree. That was 1 by root 2. Sin pi by 4 means sin 45 degree. That is also 1 upon root 2. So we know sin pi by 4, cos pi by 4, they are equal. So at the point where those two graphs are meeting, their value of x is going to be pi by 4. That's what at least from the graph I can see, I can observe. Now we study these two graphs in interval 0 to pi by 2 section wise. Now my first part is 0 to pi by 4. Like how we are observing. My x is here between 0 and pi by 4 somewhere. That x means it is greater than 0 and less than pi by 4. Okay. And then I observe that the pink dotted line what I have shown, that is the perpendicular drawn from graph of y equal to sin x. Okay. So that height is nothing but sin x. Now similarly, if I go up and I meet the graph of y equal to cos x, then that dotted green line shows that that is the value of that length would be value of cos x. Now which is bigger? I can see from the graph that cos x length seems to be bigger than that sin x. So my first observation is sin x is smaller than cos x. That happens in 0 to pi by 4. Now, as I have already mentioned, that at x equal to pi by 4, we will observe that cos x and sin x, they are going to be equal. That is observed from the graph also. I have shown in blue and red part. Okay. So, my observation at x equal to pi by 4 is cos x equal to sin x. Now, go further and take that as third case. The third case is that we are observing the graphs in pi by 4 to pi by 2, this region. So my x would be somewhere here between pi by 4 and pi by 2. Now do that similar exercise. Now I'm showing that green part as length of cos x because that green dotted line meets the curve y equal to cos x. So that height, that length of dotted line would be nothing but cos x. Now extend that further and go up to graph of y equal to sin x. So that pink part, pink dotted line shows that would be length of sin x. Now which is bigger? Length of sin x part or length of cos x part? So those dotted lines I mean. So I observe that sin x is bigger and cos x is smaller. So I will write cos x is less than sin x. So in this way, in given interval, you can draw two graphs, and one thing you can, like understand from here, that graph which is at lower position will be smaller and graph which is at upper position will be bigger. So this is what we have done, especially in 0 to pi by 4 and pi by 4 to pi by 2. Okay, this is my first example. Now let us move further from here. Okay, and that is now I try to take three functions like y equal to tan x, y equal to x, and y equal to sin x. Now, idea would be similar to like what we have done just now, that we will be comparing these graphs, that y equal to tan x, y equal to x, and y equal to sin x, and interval still I am taking as 0 to pi by 2. Now, why 0 to pi by 2? This is just an example. You can study in other intervals also. Method will remain same. Now, in 0 to pi by 2, I try to draw three graphs, y equal to sin x, y equal to x, and y equal to tan x. Now, some of you, those who do not know that y equal to x is a line, my request to you is that you can do this simple exercise. Y and x, these are going to be equal. Means what kind of points in coordinate geometry I'm saying? You are expecting on this line, y equal to x. This is the description of a line where points like 1, 1, 2, 2, 3, 3, etc. are going to lie. So join them, and when you join, you will get this as a straight line. So y equal to x, y equal to tan x, and y equal to sin x I have drawn here. Now we have to compare them in 0 to pi by 2. So I take that x somewhere here between 0 and pi by 2, and then similar idea we will be using, that I draw that green dotted line which is coming from that graph of y equal to sin x. So that length of green dotted line is nothing but sin x. Okay, and then that blue dotted line shows me that length is going to be x. So which is bigger? Now x is bigger than sin x. So in 0 to pi by 2, my first observation is sin x is less than x. This I am doing only taking two functions at a time, because we have done just now comparing two functions at a time. Okay, so I have compared now here y equal to sin x and y equal to x. Okay, now we move further from here, and now we will be trying to see what happens between graph of y equal to x and y equal to tan x. So that dotted blue line still works for that x, and now that pink dotted line which is coming from graph of y equal to tan x will represent, that length would represent tan x. Now which is bigger? Tan x is bigger than that blue dotted line, right? So my observation here is x is less than tan x. So in 0 to pi by 2, I observe sin x is less than x, and I also observe that x is less than tan x. Now, can we combine these two and write one inequality only? And that is nothing but sin x less than tan x. Now, this is a standard result. You know, like this becomes somewhere some initial step to start a question. Now, this I'm taking here as an example. So don't be under impression this is just some question, and now if I know its solution, I would leave the solution here itself. No, you can take this as a result and keep in your mind that in 0 to pi by 2, sin x is smaller than x and x is less than tan x. So this is standard inequality in 0 to pi by 2. So this is how we have compared now three graphs. Okay. Now, if we move further, now before taking any other example, now can I give you one, like exercise to do, that mark the correct statement that all four options are regarding pi by 2 to pi, and we are trying to compare sin x, x, and tan x. Means y equal to sin x you draw, y equal to x you draw, y equal to tan x you draw, but your interval is going to be now pi by 2 to pi. Now hint I have given here, and now you can complete this question on your own. Okay, move further from here and take next example. Now here I have directly given you the question. You can read it carefully. Our interval is pi by 2 to pi, and those four options are talking about sin x, tan x, and x. And I have deliberately taken this question here because just now we have seen how to compare graphs of y equal to sin x, y equal to x, and y equal to tan x. So I'm sure now you can apply just now what we have done here. Okay, so I try to draw those three graphs, and my interval is now pi by 2 to pi. I have shown the origin part also, but your concentration should be only on this part, that x equal to pi by 2 to x equal to pi. Our consideration is this, that graph of y equal to tan x is below x-axis. Then this green portion of graph of y equal to sin x is seen, and now this line is seen, that y equal to x over pi by 2 to pi. Okay, now what do we observe here? Now, if you see those four options carefully, then you get some hint that from where to start. I can see that in 3 options, tan x and sin x are compared. So try to deal with first sin x and tan x only. Perhaps in one shot only you will get your answer. Okay. So y equal to tan x and y equal to sin x do not meet at all. You can see in pi by 2 to pi, y equal to sin x is here and y equal to tan x is here. Now some of you may say that at x equal to pi, those two graphs are meeting. But mind you please, here our interval is open interval. Open interval means those two ends are not to be included in the required interval. So since x equal to pi is not in the interval, so in that open interval pi by 2 to pi, I'm sure that graphs of y equal to sin x and y equal to tan x, they do not meet at all. That means at no position tan x and sin x values can be equal. So sin x equal to tan x has exactly two solutions. This is wrong because it does not have any solution actually. So sin x equal to tan x for at least one value of x. No, that also doesn't happen. Now the equation tan x equal to sin x has exactly one solution. It still doesn't happen. Why? Because those two graphs do not meet at all. So I can write from here that for no value of x, sin x is equal to tan x. And from here, I observe that tan x equal to sin x has no solution, and hence I can say that options A, B, D are surely not correct. So now don't jump to option C immediately. Now make sure that option given is also correct. Question should not be wrong, right? So we go for now third option, which needs y equal to tan x and y equal to x. So try to see what happens to y equal to tan x and y equal to x in interval pi by 2 to pi. And we realize that y equal to x is somewhere here over pi by 2 to pi. Okay. And y equal to tan x is below x-axis, means values of tan x are negative. And when you see graph of y equal to x, we realize that all x what you are taking, they are positive because they are anyway in pi by 2 to pi. So tan x and x will never be equal in interval pi by 2 to pi. So they do not meet at all. So my correct option is C. Okay. This is how we have compared graphs of y equal to x, y equal to tan x, y equal to sin x by taking 3 different examples. I'm sure now you know how to compare graphs. Now, this does not mean that you should know only to compare graphs of y equal to sin x, y equal to tan x, and y equal to x. Now you have idea. Even if I give you y equal to cos x, that graph you can compare with y equal to tan x or y equal to x, etc. Whole idea is that on the given interval, you draw those graphs and see which graph is at the uppermost position. That will have the highest value. Which is at the lowermost position. That will have the lowest value. This is how you can compare those graphs. So for this session, this much is enough, and I will get something new again in my next session. Till then, stay tuned. Thank you.